Hi, so today we are going to be running some aluminum and I have my mask with me. COVID, what can I say? Anyway, yeah. The aluminum has a slight burr and we may need to run this to a combination machine with a white belt sander. But for starter, I'm just going to run it through the DM1100 C. We set the machine to 3/16 material thickness. We are having the brushes just slightly touching the conveyor belt, so we are heavy into the material. The thicker thing, we can get rid of that little burr without it, and we are running for aluminum a relatively slow rate of about 30 inches per minute. And we are running with standard aluminum oxide blocks, not our ceramic blocks. But they are sliced so that they have better inside and outside contact. Here you see the edge coming out, and it is actually a pretty decent result. Let me check this. The outside is completely round. Some of the small holes have a little bit something left, but even they have for the most part a radius. And then this larger hole, showing in the light, you can see has a rounded edge also. It has a little bit less right here on this side, where it's parallel to the direction of the blade. So now we are going to run this, the non-burr side, but we are not going to run this at about 30 inches a minute. So I'm sorry, but when I ran the last part, which I have over here, I got interrupted by a phone call which turned the video off. So anyway, the non-burr side we ran at 48 inches a minute, and you see a very nice and rounded edge. Then we did something. Our standard block is regular aluminum oxide with a green Scotch-Brite that doesn't have any abrasive in it. And you see that these are already fanned out. This is actually a good working block. This is a brand new block. Now we put on the ceramic, because with the ceramic we may be able to actually clean those parts up. The only thing is that a brand new belt isn't as effective as a slightly worn in belt. So you see the difference between this and the difference between this. But anyway, if these belts get this burr even cleaner than the last one, then we clearly wouldn't need a white belt sander unless you wanted to also grain. Okay, so I'm going to close this up. I already set the machine to the thickness and the speed. We're going to turn this on. You may have to go a little bit harder, but yeah. So at a good angle so that we get something on all edges. This one. I can hear the bell hit, and we are going to go down, and then we'll go back down to 30 inches per minute. Right now this part is so warm that I don't even want to touch it. You see what it did to the edge. It certainly cleaned it up all the way around. So let me lighten it a little bit. Yeah, I'm going to go up by 2 millimeters. Then we're going to try it again. In this part, same thickness, 3/16, you see the burr. That was a little bit more than I anticipated actually, so I apologize for that. That sometimes happens. And like I say, this was way too hard. We will mark that with the marker. Here is the part now. Same thing, a little bit lighter. Like you see, we've got good round on the edges. We are even good on the inside contours. So now we can run both of these parts where we have the non-burr side. Here, here, and we're going to run them. And this was actually, I increased my speed so much. That was 60 inches a minute. So I'm doing it again. So here you see what is the temperature. So now we have the two thinner one, that's 1/8 inch before we were running 3/16. So all we need to do here is we're going to go down. We're first going to turn this back on again. Another conveyor belt. We go a little bit lighter. There we go. And we are going slower again. We're going 30 inches a minute. If you run aluminum, you will have to clean up your conveyor belt from time to time because the aluminum makes the powder that is very slippery, and with your small parts, especially if you have a new belt, you need to make sure that your conveyor belt is nice and clean. And that means it is light green in color. You may have noticed that it was a little bit darker before because we lost one part a little bit. So all we did is we cleaned up the conveyor belt, and now, as you can see, we have real good stick to those parts here. And we have nice temperature in it, and it comes out perfectly clean on the burr side at 30 inches a minute. And then all we do we go to the non-burr side and 60 inches a minute. That purple block is really very aggressive, and again, it actually becomes better and more efficient as it wears in, and the surface lays a little bit over, and the Scotch-Brite shortens relative to the abrasive, and this way you have more abrasive on the part. And that's 60 inch, the non-burr side. And I will write this down for you. Turn this off for a moment. So this is also, I just write purple here at this point. Purple, 60 inch per minute, non-burr side. Same here. And here on the opposite side, of course, here is a burr, and this ran at 30 inch per minute. So now we'll take these parts, and what we are going to do is we're going to simulate a combination machine between a white belt and a cross belt. So we're first going to go through the white belt. We have 180 grit on the last belt here. That's what we are going to use. And that would also be what you would be using for a grain in a number 4 finish, for example. And then we will demonstrate to you what that grain looks like if you turn it 90 degrees and you run it through the cross belt. So here, right now, with the 3/16, we have 4/5. We're going to turn this machine on. We have a relatively low belt speed because all we want to do at this point is we want to eliminate the burr and set this relatively lightly. And that may take a second pass where we can, and also on the conveyor belt, we're going to go, of course, faster than 1 meter per minute because all we want to do is we want to shave this off. So we're going to go 3. There. And I'm going to put the part through dead straight so that we have a nice inline grain. You hear that it is very quiet because the machine is barely running. As always with the white belt sander, you don't want to stand behind the machine. We are grinding with the feed direction always because that makes a better grain. For calibrating, you would grind against the feed direction. So you can hear that. The part barely have any temperature in the part, but you see how the surface is. All the burr is gone, right? And we are going to do right away the other side as well. And actually, what we can do here is we can speed this up even more because for what we are doing in terms of the graining, that'll get you a better strength. Now, we have two parts. Make no mistake, these edges are really sharp. Yeah, both sides. This is what you would cut yourself. You have a little bit of a lead in here, maybe because we went a little bit too heavy, but we have a nice and consistent grain. Now we take this and we can go in here, and I will show you the first one where we go parallel to the grain so that you can see this. 1.5, a little bit lighter here. We're going to go 48 inches a minute. You're still going to get a good edge round all the way around. Not as good as if you are at an angle, but you will get a superb turn. And then I will show you what that looks like in a cross hatch. So, here you have your buffed out surface. That's a very nice, very smooth, easy to clean, good grain. And then I'll show you on this side what it looks like to process. And by the way, the edges are all nice and round. See? So, now we run this at an angle. Of course, we put this purple blocks that we put on there was brand new, brand new. The first time that we ever used them. Again, if you break them in a few hours, they get significantly better. We don't have that luxury here today. So here we have what that surface looks like with the cross hatch. And you see, this would be better if you actually want to paint. Yeah? And that is what the combination machine is about, where you can run the grain in one direction and the cross belt in the other, and you get a very nice broken up surface that is excellent for paint. So that's parallel, and that's at an angle. So now all we're going to do is we're going to see the other half of the parts. We're going to run those also through the white belt sander here. We are on the right material. So we're going to let our thicker parts go. And then we need a reset for 3mm for this. You hear how it grinds, there's no slip because it's a solid sound. That one slips. That one is, and that's a little bit the issue. You notice that we have a black belt on this machine, and again, we would have to clean a spot. I will show you that basically, then this will work. But this belt is not as high friction as a green belt that we would have on the combination. So, if I clean a spot on this belt, and we stick this on there, and then we restart. Now the belt needs to first start up, everything needs to get going, and then when the conveyor belt starts to accelerate, that means the belt is running and going. So we will have to do the same thing on here for the small part. That issue will be, you're here now, we did not slip. So see how well this sticks. It is a question of cleanliness. Obviously it's not very practical to run this, to clean this for every part. And you don't have to do that, and especially on the green belt. kind of hard to do. Go with belt speed. There we go. Then all we have to do for this is we reduce our material thickness. Go to 3.0. And I run one at an angle. Very good. And this is what this looks like. And then we run the back side. There we go. Go back to 5. Oh. Yeah, and we still have to run the back side of this part. There's a mess going on here. I apologize for that right now. Again, we go back to 4.5. Or 4.6, a little bit thicker. Want to reload. On this nice and straight. That was run a little bit on the lighter side. That's good. That's all we want. So, well, excellent. Good up. So the DM1100 C, of course, is totally simple. All you do is you turn it on. You're going to run one parallel, this one also, and the other one cross. This is different thickness. You're going to do it afterwards. Now we're going to run this in a cross. Yeah. Mark it all accordingly, of course. So this is where the parallel is. So we're going to put this on parallel. And we need to reduce the material thickness from 4 to 3. That's it. That's how quick you set the machine between two different material thicknesses.
You see, it is way faster than if you have an automatic machine where you need to go to a touch screen, where the machine needs to stop, where it needs to reset its position, verify where it is. The manual hand crank, in terms of setup of the machine, is faster than anything that you can imagine. Nothing not to like about these parts if you go for the look. And then we do the flat test on the back. Nice 45 degrees, into the best edge.